Okay, so let's jump into this video and talk about working with our knock control and our burst knock in our GM Gen 4 applications. We'll find as we're driving around, whether it's going to be at part throttle or wide open throttle, whether we're going to be at low elevation or high elevation, whether we're going to have hot temperatures outside or cool temperatures, or whether we're going to run 93 octane or 87 octane. The knock control is going to be constantly monitoring the status of knock in our engine. It's going to be doing that per cylinder, and it's going to be making reactive changes if it sees knock in real time. Now, as we drive around longer and longer, as it sees knock, it's going to have something called the knock learn factor. It's going to be learning what the knock control is going to be doing over time. If it's pulling out constant spark timing, it knows that it probably has bad octane quality. And we have two different spark timing tables to deal with. We have a high octane table and a low octane table. And depending on what our knock learn factor is going to be reading, it's going to be biasing between the tables. So if we have no knock activity, it knows it can run on the higher octane table, running higher spark timing values. And then as we drive around, if we have a lot of knock activity, it's really severe, it's going to go back to the low octane table. So it has a biasing effect and a constant adaptive nature in the knock control, which I'm going to be going over in this video. Now, we also have a predictive knock control going on called burst knock. So as we have large changes in airflow coming in the engine, it can anticipate that a knock event might happen. So it's going to pull a little bit of spark timing out based on how much airflow change it's seeing. And we'll find that this is needed because if we didn't go and have the burst knock in place, it might tax the knock control system constantly as we're giving throttle inputs. In that situation, it would constantly see that it had some kind of a knock activity, and it would lower our knock learn factor and make us ride low on the low octane table when we might not actually have to go in and pull that much spark timing out. So it's going to be a way that's going to be adaptive and predictive at the same time. There's going to be a lot of things to cover here with the knock control. So let's jump into our video so we can check everything out. Okay, so let's get started. We're going to be taking a look at our knock control in our GM Gen 4 ECMs. We're going to find that we have a whole bunch of tables to look at. We have to understand on a fundamental level how the knock control is going to work and what the tables are going to represent. So if we're going to be making any changes or updates during our tuning process, we need to know what tables to touch and what tables we need to leave alone. So let's jump in here and take a look under engine. We're going to go across from general, idle, airflow, fuel, into spark. Now under spark, we have 4 subtabs. We have advance, retard, dwell, knock sensors. The two that we're going to be taking a look at and working with are going to be our retard table and our knock sensor table. So let's start here with our knock sensor calibration tables. We can talk about how this is going to work and how it's going to be interfacing so that we understand the retard tables and how they're going to be applied, as well as quickly going over here our high and low octane tables so we can just review that as well. So looking at this, we're going to find that we have our knock sensor level tables. There's a minimum table and an initial level table. These two tables represent the lowest learned point from our knock sensor output that we're going to consider knock to occur. Now we also have our multiplier tables here. These are going to be multiplying against the values here. So these are going to be the start of what it's going to be looking for, and then as we move into our multiplier tables, these are going to be raising that threshold up. So essentially this is going to be a threshold levels that we're going to have to exceed in order for the ECM to consider it to be a knock event. So the way a knock sensor is going to work, it's going to be essentially a microphone. It's going to be mounted to the block, and as a knock event occurs, there's going to be small pressure waves that are going to be transmitted through the block. The knock sensor is going to act as a microphone, and it's going to send out a voltage output based on the amplitude or the audible level of the knock sensor. Now, knock can occur and we can't audibly hear it with our ears, but a knock sensor can pick it up. There will be situations where we actually can physically hear it with our ear, and it's going to be a pretty severe event at that case, and then it'll also be reported in that manner by having a higher voltage output